Okay, so phones away, computers down, please. Today's and tomorrow are going to be kind of a weird day. First 2 hours are done with the test. The next 2 hours have one day in. My sixth hour hasn't even touched the test. My seventh hour's got 10 minutes on the test. So today and tomorrow is going to be, I'm going to be taking what should probably be one day and kind of stretching it out over about 2.5. I got my screen froze, sorry. So we are going to be starting a unit that I'm calling Water and Weather. And with our Water and Weather unit, I do have a folder for it. In that, there is my additional materials, and I started the calendar on it, but I haven't done a really good job. Wow, we're running slow today. Just because everything is kind of up in the air. How do I make this? There we go. One thing that I want to point out is we are here. These are our MCA tests. You have a math test, a reading test, and a science test. And in 8th grade, we do one test a day, and it's not totally finalized, but I will be spending some time next week trying to make that as clear as possible. Anything that I know about the test, I will make sure that you know about the test, and we will talk about that. The water and weather are normally two separate units, but I am going to put it into one just because a lot of the stuff in the water unit you learned about last year, and I'm extremely behind. So we're going to kind of take and condense it down. When we take a look at water, and if we take a look at going to a different planet to live or anything like that, we have to have water. Water is very important. When I started teaching, no student had a water bottle. It did. Every now and then a student would ask for water, but the mindset that we've realized that when you are dehydrated, you don't learn as well. Hydration is good for the brain, it's good for the body. You are about 70% water, and you got to keep that level up. And if we take a look at water, only 3% of the water is drinkable. And the technical term for drinkable is potable. I'm not going to test you on that, but if you ever see the term potable or non-potable, if you see non-potable, don't drink it. They're saying that there is something bad in there or it's not good. And of that 3%, 75% of it is frozen in the polar ice caps. Will we ever be able to get that 75%? When the polar ice caps melt, where does that water go? Anybody have any idea on where that water will go when it melts? In the ocean. Can we drink it then? No. There are states that desalinate water, but it is very expensive to desalinate water. Water is a big business. In Fairmont, we get our water on the south side of town, the south side of the lakes. And what the weird thing is the water flows from the south to the north. So we pull it out here, and all of our wastewater is treated and put back in on the north side. Now, for me, I would love to see the city take the water from the north side instead of dumping it down a creek on the north side, putting it back in on the south side. What that would do is that would add more water running through our lakes. Now, the problem with that becomes, do you want treated wastewater in your lakes? How does that sound? Yeah, a couple of you are shaking your heads. That doesn't sound good. If you live on the International Space Station or if you visit there, all of your fluids are recycled. Okay? They take moisture from the air, they take moisture from your stools, and they clean it, and that goes back into drinking water. This weird thing is the wastewater that they dump down the creek is cleaner and better than the water from our lakes. So if they were to take and recycle that water, it would be cheaper. But the stigmatism that's going to come with that is horrible. You're drinking wastewater? So to me, that's one of the things that I would love to see Fairmont do. It'd make our lakes cleaner. It would send water over the dam, which would send some of the green stuff down and make it better. And the other thing that's really hard when we talk about water is conserving water in Martin County. Have you ever seen a shortage of water in Martin County? No, we don't see it. In fact, if your family's a farmer, they spend a lot of money to get the water out of their fields. Okay? I mean, tiling is a big business in Martin County. If you drive around, you can see, farmers that are tiling. The reason why they're doing that is to try getting the water out of their fields. Okay? So we don't see the shortage, but there are places that have shortages. All of our weather is related to water. Okay, if you don't have water, your weather is kind of boring. Take a look at a desert. Same stuff every day. Okay, so we are going to hopefully take a look at how water and the uneven heating of the earth gives us weather. Water, I think of it as a Mickey Mouse head, and I cannot remember how much I went into this when we did our chemistry unit. I don't remember the chemistry unit at all. Were we here when we did chemistry, or were we distance? Anybody remember?
I think we're distance.
Both? Okay. Mickey Mouse head. This is a model of water. The ears are hydrogen, and the head is oxygen. The ears will become negatively charged. The head will become positively charged. And water is what's said to be a polar molecule, which means that it has a positive side and a negative side. And that's what gives water a lot of its properties. So water is sticky. And the reason why water is sticky is because it has a positive side and a negative side. Can anybody think of something that water might stick to? Your hand. You. Think about getting out of the shower. If water didn't stick to you, you could just go. And you'd be dry. All the water would fall off from you. Some of you may have a dog. A lot of times retrieving dogs, when they get out of the water, what do? They shake. Dogs, well, unless you give them baths, have oil on their fur. And that oil is designed to keep water up. That will keep them drier because the water doesn't stick to them. And you as humans, if you don't wash your hair will become oily, and that is going to be something that is non-polar. Bacon grease, hamburger grease, butter, lard, Crisco, those are things that are non-polar. If you snowmobile, or if you ski, or if you're in hockey, or your windows a lot of times on your cars, you can put something in on them called Rain-X or Fog Away. And for the most part, you put a layer of non-polar substance on it so that the water won't stick to it. And the same thing could be done as if you use bacon grease, okay? Because water won't stick to it. It'd be kind of gross, but it won't stick to it, okay? Water is found in all three phases in the atmosphere. It is the only substance that we can find a solid, liquid, and a gas. Okay? Now, water vapor is the term used for the gaseous phase. And that becomes one of those things that is hard because a lot of times people aren't going to say water vapor. But water is normally the liquid stage, ice is a solid, and water vapor is a gaseous form. Another unique property of water is that when it turns into its solid form, ice, there are voids in between the crystals. which makes the density go down. Most solids, when it goes into its solid form, the density goes up. But because it goes down, that gives ice the ability to float. What would Fairmont's winters be like if ice sank? What might change? You wouldn't be able to go on the lakes. Where would all the ice be? In the water. So the lakes would freeze from the bottom up. Now that would make ice fishing kind of easy when it got to the end because all the fish would be on top. The only problem is our lakes would freeze solid. Because the ice is on top, it insulates it and keeps the water from, on the bottom, freezing solid. Now that doesn't happen all the time. We do have lakes that freeze out because our lakes aren't very deep, but that is one of the properties of ice. It floats, its density goes down. With water being sticky, water sticks to itself. And when water sticks to itself, that is called cohesion. Last year you did the paper clip, how many paper clips you can float, correct? Okay, that is cohesion. On the bottom left-hand side here, maybe you've seen the bugs that walk on water. The reason why they can walk on water is because of cohesion. And that is the water sticking to the water. Now, at the surface, we call it surface tension. And you may not realize how strong this is unless you've done a really good belly flop or a back flop, or that person that was driving the boat and you were on the tube, hit that corner just right and you went skipping across the water. Well, the reason why I did that is because water is very sticky. It's hard at the surface, okay? If water sticks to something else, it is called adhesion. Now, I like to think of adhesive tape, upper right-hand corner. That means that the tape is going to stick to something else. Now, here's something you may have not thought about. Does tape do a good job of sticking to tape? If you stick the sticky sides together, but how about a sticky side to the back side? It's designed to not stick to itself very well. It's designed to stick to something else, okay? So that adhesion is going to be when water sticks to anything else. And once again, it's going to stick to anything that is going to be polar. Water has a very high specific heat. Now, the specific heat is how much energy does it take for the temperature to go up. Some of you have, how many of you have already jumped in the lake? Anybody? No one in this hour? One? Okay, how was it? Cold. It takes a while for the lake to warm up because it takes a lot of energy. Now, the first day it's 80 degrees out and you're standing on the beach, that sand is going to be hot. You go into the water is going to be cold because it takes a long time for that water to raise up. Now, the flip side of it is it takes a long time, or it has a lot of energy that it can give off. Our building is heated by a boiler. So over there, if you're in the commons and you envisioned looking north and down, there's a boiler. We actually have two boilers, and they pump hot water throughout our whole building, and the water will come out. It'll open up into a radiator. That energy is taken out and put into our room. Some of you may have a house that has a boiler in it, okay? Very efficient way of moving energy, okay? The only problem is it's not very efficient for cooling your house. It does a great job for warming it, but it doesn't work for cooling it. That's one of the drawbacks. Now, if you've ever done any cooking, you may have used cast iron. The philosophy behind cast iron, or if some of you have ever done Dutch ovens, the idea of a Dutch oven is you put everything that you want in there and you stick it right in the coals. And as you stick it in there, it takes a while for it to warm up, And it warms up and it warms up and it warms up, and then the coals die out, and then the temperature levels off. Now, if you used, let's say, an aluminum pan, and you stuck that aluminum pan in the coals, everything in there would burn, because aluminum has a very low specific heat. That energy will flow through it really quickly. Copper has a low specific heat. Gold is very low. Okay, that energy will flow through it. Cast iron has a high specific heat. Okay. This is a kind of a unique video that I'm going to show. But I just realized that I didn't share my audio with my people at home once again. So give me a second.
Han ser rädd ut faktiskt. Ja, ändå. Nej, men det är 50 år att man sätt upp linjer. Han går igenom. Titta stollar, titta stollar.
So why didn't he hit the ground? What kept him from dying? The water. So the water has a very high surface tension or cohesion. It stuck to himself. It slowed him down enough that he didn't die. Okay? So that's one. And the next one is showing the properties of the specific heat.
If we take an ordinary paper cup and heat the paper cup, it very quickly bursts into flames. If we take a paper cup and put water in the paper cup, it doesn't burst into flames. We can actually boil water in the paper cup. The water has a very high specific heat due to its hydrogen bonding. It also has a high molar heat of vaporization, also due to the hydrogen bonding. The water absorbs heat rapidly, and so rapidly that the paper never gets up to its kindling temperature. We've added a little food coloring to the water so it makes it easier for you to see the water boil.
I'm pretty sure I showed you a Bill Nye video on pseudoscience and about Bill walking across the coals. That's the reason why you can walk across the fire, the coals, is because of the blood in your body is going to take and absorb that energy and not burn your skin. So with that polarity, water becomes what's called the universal solvent. Given enough time, energy, and pressure, it can dissolve anything. And some of the things that you might go, that you think would be hard for it to dissolve, like lead is really not, or iron, really isn't that hard. If you live in the country, you may have iron in your water. And if you have iron in your water, that is true iron that is dissolved. At one point in time, almost all of the iron on the earth was dissolved in water. All of our iron, most of our iron that we mined was precipitated out of water. And once that iron in the water mixes with oxygen, it becomes iron oxide, and the solubility of iron oxide goes down and it precipitates out. So if water is the universal solvent, what do we need to dissolve those things that don't, or that aren't polar? So let's say you're working with bacon or hamburger, or you just got done rubbing butter around the edges of your pan. How do you get the butter off your hands? Or bacon grease? What do you use? What do you use to clean your hands, hopefully? Soap. So soap is a very unique molecule also, when it's a huge molecule and the very end of the molecule is polar, which means that it'll stick to water. The other part of it is non-polar, which means that it will stick to the grease and the fats. Those things that are non-polar will stick to this side. That side will stick to water, and the water will then take it out of the way. And I'm not quite for sure what all you learned about in 7th grade. I just know that Mrs. Holm did a water unit.
For years, something stopped me from buying Dawn. This, a piece of fruit, stood between me and the best way to clean grease. But I'm a lemonette, just love the smell. So I gotta have a lemon liquid. But there wasn't any lemon Dawn.
Until now. Introducing Lemon Scent Dawn. New Lemon Scent Dawn breaks up grease, takes it away, and helps keep it away.
Lemon, Dawn, now we're talking.
New Lemon Scent Dawn takes grease out of your way.
So
Now we're talking.
So this scene right here, what's happening is there's water, on top of it is grease. The grease and the water will not mix because they're non-soluble. Okay? I think I may have talked about this when we did chemistry. Italian dressing. Okay. It's been so long, it seems like forever. They're not soluble. They won't mix. But as soon as that drop of dish soap or soap gets on there, that molecule, one side is grabbing onto the grease, one side is grabbing onto the water, and it's going to break the surface tension. I think.
New Lemon Scent Dawn takes grease out of your way.
So, the time that's left, I did not put stuff in Schoology just because I don't know if it's going to work. So the time that's left, and I don't have it where it should be, but I would like you to go into the water reading. If you open up, there's two chapters that we're going to be working on. Section 1 is what I would like you to read. Right here is atmospheric water worksheet. And I think it was my 7th hour that I handed this out to. They're like, it's 8 pages long. Yeah, that's all of the sections in one worksheet. Okay? I'm not expecting you to get it done today. And I'm not going to probably assign all 8 pages. But what I would like you to start working on is section 1. The reading is the water reading. It is there. And the book is kind of messed up, so it starts off with the first page of that. But it is there, water in the atmosphere. And then the worksheet is, where'd it go? Water reading. Oh, yep, no. Weather reading, atmosphere. Oh, atmospheric water, sorry, worksheet is there. Now, this is not what I've talked about yet. This is about the next thing that I'm going to talk about. Okay? Now, for some of you, you're going to go, wow, you know what, Mr. Liebert, this topic is really elementary. Talking about evaporation and condensation and a lot of those words you know. But you may know them, but hopefully by the end you can understand how and why, and then we can take a look at what impact it has on weather. Okay? So the time that's remaining, if you could start reading, and you can either read yourself or you can listen to me. I didn't label that very well, but section 1, that's a video of me reading if you want to listen, and then the worksheet. If you go into the hallways, please, I don't know if you've been hearing, but the students have been getting quarantined hugely lately. Okay? They're no longer doing it over the announcements. They're coming into classrooms and escorting people out. So please, give yourself some distance. Okay? Keep the nose covered, please. Okay? I know if you get COVID, hopefully you won't die, and hopefully you don't get very sick. But I'm vaccinated. I can still get it. I can still spread it. The vaccine just keeps me from getting really sick. Okay? So you're more than welcome to head in the hallway if that's what you would like. Those of you at home, you are free to leave Zoom if that's what you would like. The rest of the time is work time. Have yourself